we have seen how a linked list is being formed. It is a collection of nodes, and each node will be having at least two fields, one of which should be a pointer to a node of the same type. So it's called as a self-referential structure. So we can perform many operations on a linked list, namely insertion, deletion, traversal, and searching. In the previous classes, we have created a linked list and we'll be using some of these operations in the coming slides. So let us see node insertion first. A node can be inserted at three locations. One is at the beginning of the list, then at the end of the list, and finally between these 2 points, that is as an internal node. Beginning and end are the external nodes, and in between these two nodes we can insert a node. So three types of insertions are possible in a linked list. Let us see insertion at the beginning. We know that a linked list is identified by a address, which is the address of the first node, very first node. Normally it will be declared as head or start. So we are using head here, for example, and this is an already created list, list having 4 nodes. We are adding this node, which is a independent node with address 1000. These nodes have addresses 5000, 3500, 4000, 2200, and so on. So we need to add this independent node at the beginning of the list. So when it becomes the first node, the list will be having 5 nodes altogether, and the head should, by default, head should always point to the first node of the linked list. So when a fifth node is added at the beginning of the list, this head should always point to this new node. So we have created a new node by using malloc function, and we have assigned value 15 to it. So if new node is the name of this node, it is having two fields, is the data, and another is the next, which is used for pointing to other node. So we have assigned a value 15 to it and null to the pointer, so that it is now an independent node. So we are trying to add this node at the front of the list. This is the simplest way of addition because no other process is being involved. We need to just link this head to this node and this null to this node having 43 as a value. So let us see how it is being done. So after addition of this list, node, the list look like this. This will become the first node. Normally head will be having address of this node, the new node. Earlier it was having the address 5000 because the node representing 43 was the first node of the linked list. Its address was 5000. So head was having the value 5000. But now when the new node is being added to this list, its address should be contained in this pointer head. So head should point to the value 1000, or head should have the value 1000 instead of this 5000, where 5000, which was the value of head, should be entered at this location. So new nodes next is being replaced. It was having a null value. It is being replaced with 5000 so that this node is being pointed to the first node which was earlier in the list so that it becomes the second node. So in the process, this becomes the part of this list. So what happened here? The value of head which was 1000 is being assigned to the next pointing location in the new node, and the address of this new node, which is happened to be 1000 for example, is being assigned to head. By this process, we have added a new node to the already existing list. So new node with data 15 is to be inserted at front. Address part of new node, this is the address part of new node, should point to head node. This was the head node first, so this should point to the head node. That means this 5000 should be entered here, and the new node is made as the head node. This should be the front of the linked list, so the head should point to this node. That means 1000 should be transferred into this head pointer. Now when we need to insert a value or node at the end of the list, we should do an additional process of traversing, or we should reach to the end of the list. As before, we are having a new node with the same value 1000 as its address, and we have its data part or information part as 15, and this link is being initialized as null so that it is an independent node. So this node has to be added not at the front but at the back. So we need to travel from this end to this node, and we have to attach this independent node at the back of this final node. So when we do that, this node representing 43 will be the start of the linked list. The head will not have any change after addition of this independent node because it is being added at the end of the list, so the front remains the same. So we will not be altering the value of head in this case. After this operation, the list will look like this. This is the first node, second remains the same, so as 3 and 4, and null part of this final node is being pointed to the new node. That means the pointing part of this final node should have the address 1000. So when we form a linked list, here we will be having the address of the second node, that is 3500 here, 4000 here, and 2200 here. Then only we can visualize this collection of nodes as a list connected by these links. So we should have 3500 here, 4000 here, and 2200 here. So finally it was null here. Instead of pointing this pointer to a null value, it should point to this node, and the address of this node is 1000, so naturally this 1000 should be entered at this location so that this link is being formed. So this is the front node, or head will be having the same value of 5000 here, and this will be the first node, second, third, fourth, and this becomes the final node. So we have an additional process of traversing from first node to the end of the node, or moving from first node to the end of the list and then only we are adding an independent node here. In the previous case, it was not the case. We don't need to travel through this linked list. We can directly insert this independent node at the front of this head. So insertion at end is like this. Now a node can be inserted as an internal node, so that these are the external node. This is the first node, this is the last node. Anything in between can be considered as external node. By the addition of this independent node between these two, it also becomes an internal node. So at any location we can add this node between these two nodes. So first of all, we have to identify the location either by value or by counting the number of nodes. And suppose if I say this node has to be added after the value of 23, then this node appear here. Or if I say that this node has to be added as the fourth node, then this is the first node, this is the second node, this is the third node, then also it appears here. So the condition can be changed either as the count of the node or as the value in a node. So anyway, we have to find the location first. For that also we have to do an additional work of traversing or moving through the list up to a point where we have to add this node. We have to find that location first. The rest of the things are same as before. So we'll be having the value 5000 at first. No other values are available. So in the head pointer we will be having the value 5000. When we move into this, we can have the value of 3500 or the address of second node here, and the address of third node here, and the address of fourth node here, and finally it will be having a null value. So while moving from this to this, we can count the number of nodes, or we can search for a particular value and find the location where we have to add this independent node. So first we have to do that. So we'll be entering into the head first. Suppose that we are inserting this node as the fourth node. When we reach here, we can count the node as 1. From there we can move to this node, which is node number 2, and this becomes node number 3. At that point, instead of pointing the link of the third to the fourth node, that is, it was having 2200 here, the address of this fourth node. Instead of having this 2200, what we have to do, we have to replace that 2200 with this 1000, and the null portion here should be replaced with 2200. So the value which was here should be copied to this location, and the value of that independent or address of the independent node should be copied to this location. First this copying should be made here, and this copying should be made next, so that this forms a linked list in this fashion: first node, second node, third node, fourth node, and fifth node. So in this way we can add an independent node internally as an internal node between the first and the last nodes of a linked list.